What I'm here to talk about today is mathematics and Down syndrome. I'm a maths teacher by background and a researcher in Down syndrome, so I bring a few things together. But why I do research is actually my little blossom there. This is Ruth 25 years ago now. Can you believe it? I can't, but you're seeing her for the first time. Gorgeous in her little basket. And back then, there was virtually nothing known about how to help her do maths. And I really learned along the way as she grew. And here she is more recently. Ruth's now finished school and she went on to college and she studied a vocational certificate in childcare and she works in a childcare centre. And living the good life, let me tell you, living the good life. And it's quite a joy to see, and some of the very funny things that go on in our life. As those of you who live with people with Down syndrome will know what a joy it can be. And Cara, I empathise with your question, which we will tackle as we go along, I would hope. Um, it's about living with an adult with maths difficulties. So in terms of learning mathematics, well, what might be possible? Now, if you listen to most research and if you read most of the papers, they paint a pretty depressing picture. And we would be saying, well, not much. And certainly when to read, and I was hearing, my goodness, they can't count past 20, they're always going to have trouble, and maths is going to be really difficult. Well, what they didn't really tell us was that they weren't actually talking about maths. They were talking about number. They were talking about arithmetic. And they hadn't really explored anything else in mathematics. So we needed to think about, well, what actually is possible. So the story's changing a bit. And the story's changing in some quite fascinating ways. And I guess along the way was learning a lot from people in Europe and in Italy in particular, and some of the quite remarkable papers that were coming at our way that were suggesting if we actually just tried teaching some significant mathematics, it'd be surprising what they could do. And so when Ruth was a little one, probably about, she was there and just starting secondary school, starting high school. So she would have been in about year 8, which would have made her about 13 years old. In her class, her teacher asked her what 5 plus 5 was, and she said 25. And as I want to say, I actually think that's not too bad because at least we know what she was trying to do. But it's actually it really is a problem if you're trying to teach secondary maths to a class of students and one in your class can't do single digit addition. Well, her teacher wanted to do what she'd been trained to do, which was go back to where Ruth seemed to be and teach her year 1 work again. But the trouble with that is that Ruth had had good teachers through primary school. It wasn't that she'd not been taught it. And so the chance that she'd actually learn it then was just pretty small. And so really what this teacher was going to do was a whole lot of extra work that probably wouldn't have been very successful. So instead I asked her if she wouldn't mind having a try at teaching just what she was going to do with the rest of the class. And that topic was percentages. Now, anybody who's done percentages as a teacher knows it's jolly hard to teach. And so this woman was a particularly brave teacher. Now, a few weeks, as in only about 2 or 3 weeks after she'd asked her what 5 plus 5 was, this is the homework that Ruth came home and did. Oops. There we go. Oh, that's no good. Media's not there. Never mind, I won't find it because Ruth just works her little heart out doing that. And this exercise that you can see, and thanks for the chat, I've just realized I need to speak slower. So I will try to do that. Thank you for letting me know. So 23% of 189 is what she's doing on the video. Now, what she can't do is the actual calculation. She uses a calculator to do that. And by using the calculator, she's actually getting the support, but then she can go on to do more mathematics. Okay. So what I'm wanting to do today is to talk about why we should bother teaching mathematics. Why do our students with Down syndrome seem to get stuck on number? What are some strategies for teaching maths? And I'm hoping to leave a good bit of time for your questions, because there are lots of things that I've learned along the way and that I haven't put into this talk. And you might well not be terribly interested in what I've got in the talk, but you might want to ask some questions. And so that would be good. Now I can see that some chats are flashing. So could somebody else monitor the chat? Because I find that difficult to do at the same time. Okay, so why should we bother with maths? And for people like me who love maths, that's sort of a question that you'd think, well, why not? But it's a surprising thing that there are some people who don't particularly like maths. And one of the challenges sometimes is to convince people that it's actually good to do mathematics. And for people with Down syndrome, it's really important for them, but also they love it. They actually do love it. Once they get into it, they love it. But like all of us, when work is hard, when it's repetitive, when we don't seem to be making progress, when all we seem to do is just get things wrong, who would enjoy that? Nobody. So what we've got to do is think, how do we make this subject accessible? How do we help learners to learn? We also need to think about what mathematics we teach, because what we once needed has changed. So I've got a picture of an old cash register, and I'm truly old enough to remember when we used these in shops in Brisbane. The picture on the right is a bank book. I don't know what you were used to, but this was very recently still and in use, where you'd go to the bank teller, they'd write by hand in your bank book and they'd give you the money. Those sorts of things in my lifetime have changed. But sometimes the curriculum that's taught to people with Down syndrome is exactly what was taught in the 1970s. So we want to think about how we change what we teach. Things are going to keep changing. We've changed in finance. We now do things electronically and they keep changing. So we've got PayWave now. We've got bank apps on our phones. I'm sure you do where you are as well. I don't have these things, but people have watches that they can just pay things as they walk past. And in Australia, and maybe where you are, we have virtually completely removed cash because of COVID. So you can go into places and they will not accept anything other than tap. So if we've spent a lot of time teaching people with Down syndrome how to count out coins and how to hand over a note and work out how much change we're going to get, it's been a waste of time, because we need to teach other things that are much more complex about how you manage money, how you make sure you've got enough, particularly when you're just tapping your card. Oh, isn't that easy to do? How do we make sure we've got enough? Not necessarily exactly how much, but have we got enough? Those sorts of things are meaning that we need to think about how we teach mathematics and what we teach. One of the things that struck me when I first started working in this area was I did a study talking to people as adults and looking at the use of mathematics they made in their lives. And one of the things that really struck me was how efficient learning was in the context. So they might have been doing a lot of work in school, but it was when they were needing it for their work or what they were doing as adults that they could learn it very efficiently. And they also made a surprising mix of use of mathematics. So they made a surprising mix of mathematics, lots of geometry and other areas. A strange sign just came up with please move. So is there a problem? I'll keep going. Cora? No. Okay.
It's okay. Everything okay?
Oh, good. Excellent. Thank you. Rolling right along. So maths is broad. It's broad and rich and much more than number. And in Australia, we have curriculum strands which are pretty similar around the world from what I've been able to gather. We teach number and algebra, we teach measurement and geometry, we teach statistics and probability, and all of these things get wrapped up around how to think mathematically. And these things are really important for us to do and not get stuck on number, which happens too often with kids with Down syndrome. And we can see that there are other aspects of mathematics in the first picture about measurement, where that's done without number, the geometry of shape and position, that's done without number as well. But let's think about number because it is an issue. Well, it's nice to know that we're all actually maths geniuses because when we were born, it's probably as soon as we can actually be a baby there, within hours perhaps, we can already add. We can add 2 and 1. We can add 2 and 3 and 1. We can take away 3, take away 1. We can tell the difference between 4 and 20, but we can't tell the difference between 19 and 20. Now, you might think, gee, that's pretty remarkable. As a baby, we could already do that. But then we don't get too cocky. We don't get too big for ourselves because animals can also do this. They've found that dogs and pigeons and horses and elephants and rats and lots of other animals have this sense of approximate quantity. But there's something remarkable that humans do. And what humans do is develop language. And we use language to then move our concept of number into a whole new area. So we begin with this sense of quantity. When we get our language, we peg all of those ideas of quantity into those words. And so with the language, then we can go from an approximate system to an exact system. And we also use the symbol. So if I have the symbol for numerals, I can write it in all sorts of different ways. But that symbol is something that humans invent and humans teach to their children. When we develop language, we have a word, it's a human invention, we tag the symbol to the word and the quantity as well. Now, we need all of those together. And it would seem that our learners with Down syndrome really need that symbol. So they seem to get the symbol and then tag the word to that symbol. That would seem to be a bit different to other children, but once they've got that concept of number, they're away. So what we should be aiming to do is give lots of opportunity for our learners, our little ones, to focus on the symbol. And there's some things that these are called feely digits. They're nothing too remarkable. There are lots of ways of making symbols these days, but there's some I made a long time ago. And so there's the 5. And so you've got cardboard and something nice to feel underneath it. And so the child can then trace around with their finger. Now, you can see that 5 on its way to being made. So it's a piece of card that you stick together with the stuff in between it. And I hate craft. And so the one time I did it, I took a picture and I'm never doing it again. But lots of other things are around there for those of you with little children, lots of things that aren't on the iPads, though there are plenty of those, but the opportunity to play and explore away from a screen is pretty important. Number lines are really important. A number line becomes, and I've got a visual for that in a minute, but that number line eventually goes into a mental number line. So adults with a good sense of number have a mental number line, and in their head they can see, well, if zero's here, where are the positives, where are the negatives? I can see on my number line that 2's here and 20's out there. I've got a sense of where these numbers are, and we need to encourage that in our learners with Down syndrome, but all learners. Hundreds charts are really important. So that's an array where you've got all the numbers 1 to 100 or 0 to 99 in that chart. They're really helpful ways of focusing in on the visual. And we want to leave them in the workspace of a student all the time. And some schools, they'll laminate them, stick them on the desk so that the child can always see the number line. They can always see a hundreds chart. So focusing in on the visual, if I love my blocks. So having a little container full of blocks is really good. And I've even got the coloured ones. Let's see if the coloured ones come out. So if I've got some coloured blocks and I want to arrange them, I want to play with them, you can see the blocks that are in my hand, but you can also see the ones on the screen. And if you think about it, if you count up in the first lot, and I can't hold them all in my hand if I had that many. So in this hand, I've only got 3. So I've got 3 blocks and I've arranged them as a rectangle, 1 times 3. And they're the factors of 3, 1 and 3. There aren't any more. But if I go to 4, I can arrange it as a rectangle now, 1 times 4, but I can always also arrange it, the same number, as 2 times 2. So my factors of 4 are 1 and 4, there they are, and 2. I don't have to say 2 twice. So my factors are 1, 2, and 4. Now, if we look at the pictures there, I've got 12 blocks here, so the factors are 1 by 12. The next one is 2 by 6. The next one's 3 by 4. I can't make any more. There are no other arrangements of 12 blocks into a rectangle. Now, this is work that we would typically do into upper primary and on into secondary, where we're looking at factors in numbers. So our students with Down syndrome can engage with this task in a visual way. They can have their blocks and they can work them all out. But it's not just the kids with Down syndrome who are going to like this. This is a really powerful way of seeing all the factors in numbers. Here's another arrangement. Can you guess what that visualization is showing? Have a think about it for a minute while I get some props. Okay, there's the first one. Here's the next one. And up they go. And the hint is they're squares. And so these are the square numbers. And, you know, it's rather a delight. And I think I was an adult before anybody had actually shown that square numbers were called square numbers because they were squares, and cubic numbers make cubes. And it's rather delightful. And so we can play with a lot with number, but we can represent it visually. And it's a really good thing for our learners with Down syndrome to do that. Here's some more visuals, and this actually, I think, it comes from the Netherlands, this idea of displaying percentages as blocks, as a box. So the idea that if you want to find 100% of something like $245, we don't just do it as an exercise, the way you saw in Ruth's notebook, to be fair to what happened later on in that class, they did actually go on to see what did it look like. But here, this is a visualization. So we can see that the whole lot, and it's like a download bar on computer screens. So all the way is 100%, halfway is 50%. So what's it going to be somewhere along this line? Well, it's going to be more than $100. So if we're working it out then on a calculator, we know that it's got to be around $100. It's certainly not going to be $2, and it's not going to be 2,000. So if we get a number that's completely out, we've got a sense that it's not right. So visuals are very helpful in things like that. In Australia, we have a focus on building to 5 and building 10 to 10. We use the metric system, and I know that in a lot of countries where you're from, you do as well. And it's very important to have that sense of tens. So we focus for all students on a lot of work around 10. So having visuals for that is a useful thing. But visuals are good for all of us. And I realized when I was making myself a little countdown to make sure I didn't miss the plane coming home from the World Down Syndrome Congress, I realized I use visuals. So all of us do. It's just how much we do that and show that and use that as a strategy for our learners. So this mental number line bit, this is a way of just having the numbers there is really powerful, including the negatives. But then you can use it to calculate. So if we have, I'll just get a little drawing thing. So if we start at 3 and we take away, and we teach that take away goes to the left, we go 1, 2. And we got to remember we count the hops, not the numbers. So we count the hops and we get to the answer of 1. And so we can always be demonstrating our addition and subtraction on the number line, which is reinforcing this mental number line, the image that starts to stay there in the head as a picture. Clear it all, clear it all, clear all drawings. There we go. So get rid of that and moving on. So what are the problems with number? Well, it's well known, and certainly the research is clear. They're not making it up. And those of us who've lived alongside and tried to teach people with Down syndrome, it's very well known from experience that there are some significant issues in number. And it struck me that it didn't matter which country people were working in, it didn't matter which decade they grew up in, it didn't matter who was doing the teaching, there was this consistent problem. And what we now think is that it is genuine dyscalculia, which is not just I didn't study hard enough or I didn't learn my tables. It's actually a part of the brain. So neuroscientists think they're still working on this, but there's a part of the brain that is not doing what it should. And they think it's this interparietal sulcus. And for the translators, I won't even try to spell it. We can just say it's IPS. And it's a part of the brain that appears to be designed to understand quantity. If that's not working, you have to use other circuits in the brain that aren't as well geared for it. And it can be more difficult. You can do it, but it's more difficult. And you need to use this and have lots of reinforcement, things like number lines and so on. But the good news is maths is more than number. So what we can do is introduce something that's going to help. So you're introducing a calculator is a great thing. There's Ruth, I think she's about 8 months old, and she was at her first maths teachers conference, and one of the demo people said, oh, she needs a calculator. I thought, indeed she does. So she had a great fun playing with that. And I remember the day when she was in about year 1 and she realized for the first time that the calculator wasn't a mobile phone, that it wasn't just a toy, it actually gave her the answers. That of what she was doing in her class. So you're never too old also, so we don't stop using a calculator. And the research evidence is clear that it's beneficial for all learners, all levels, at all times, for appropriate use. And things about appropriate use we can talk about if you have questions about that. So we need to teach how to use a calculator. They promote learning, they don't harm it. They also free our working memory for doing other things. So instead of having to think, oh, how do I add that? What's the number factor? Instead of having to do that, you've got your calculator, it'll do that work, and then you can get on and do the other things. This idea of a prosthetic device is the idea in medicine where if your body isn't doing something it needs, you might have a device like a wheelchair that will do that work for you, or even glasses. Um, and a calculator can be that device that does what the brain is struggling to do. And then we can get on to do other things. So that's can free the curriculum for other things. Have we got time? Not really. So I won't, there's an example, but you can do that another time. It's important to teach kids because we did a study where they didn't know how to enter the numbers in a calculator. So they were entering for 724, they were entering 700, 20, and 4. So we need to remember that these things aren't easy. We need to teach them how to use them. And there's more detail in that book. But I believe that it's absolutely essential that learners with Down syndrome have access to a calculator. And certainly we want to be teaching them other things as well, but we really must give them access. And it would be if we prevent them, and I've talked with teachers who think that, they've asked me, surely we need to make sure they can do this before we let them use a calculator. But that would be like saying, Rhonda, you show me that you can see, then I'll let you wear your glasses. Now, we just wouldn't do it. And I don't think that that's too far from what it actually is. So some quick strategies for teaching maths. It can be a bit daunting and we can think, my gosh, where do we start? But also, it's not that bad because one of the things that I did when Ruth was in that basket was go looking, trying to find the magic trick, the special technique that as a maths teacher I yet needed to learn. And I can share with you, I found the secret. And it's such a surprise that there is none. There's no special trick. It's actually good teaching. And what works for our kids with Down syndrome works for the other kids in the class. There are just important things that can just good teaching will save the day. So what you probably do need is some imagination. So just thinking, where's this kid having trouble? What are some ideas that I can do to work around that? So that's where the creativity comes in. And I've spent a lot of time over the last 5-10 years working with teachers who are really good at working with kids with Down syndrome in their regular classes. And it's great to see their creativity. They have a sense of humour that things don't always work, but tomorrow's another day. And they're ready to have a go, just try things and see if it works. If it works, great. If it doesn't, they don't give up. They look for other ways. So here's an example of a teacher who did a really creative thing. So this is a student who was in year 9. So he was about 14, 15 years old, getting a worksheet like that. Now, he got a worksheet like that. He knew it was babyish. Everyone else knew it was babyish. And what's more, he knew he found it hard. So he was not happy. Neither was his teacher because his teacher wasn't making much progress and his parents wanted more. So the teacher asked for some ideas and I said, well, look, how about what are you going on? What are you doing with the rest of the class? And she said, well, we're doing linear algebra. I said, well, what would you feel about that? And she thought, I'll have a think. Well, very quickly, she had a think And this is the worksheet that she did. So solve for y equals x plus 7. And so what we do here is we take the various values for x and we put them in here, and each time we add 7. So this student's actually doing a whole heap of practice of adding 7. But instead of it looking like a year one, it's now looking like the other kids in the class. He's doing algebra and he's loving it because instead of looking like a baby, he looks like a cool kid in year 9 who can do algebra. And they love it when they can do it. And his worksheet was done really fast. So there was a teacher who took something very quickly, thought, I can do this. How do I do it? And great results. So this is what we call year level appropriate curriculum or year level adjusted curriculum. So we start with the year level for whatever they're in, and we think, what are the blocks? What's getting in the way? What can I do to help this learner? And here's a student in year 8 whose teacher tried this. And so you might be able to see at the top of the screen, the question was 24 plus 4p plus 3p plus 3. And here's this lad, he's still learning to add 4 and 3, but he's doing it now in the context of algebra. He gets a big tick at the end. Even though it's a bit hard to read his writing, we can get there. It's great stuff to do, and we're seeing really dramatic work results. So you start with the curriculum for the year level. You find out about specific learning issues. If you've got parents or some people who've worked with the student before, you explicitly plan the adjustments. You just think, now, what's going to work here? Where's the block going to be? What am I going to need? And if you've got teacher aides, you give them the information of how to help. And then you give them lots of practice. And then you don't wait just for the test. You actually test each as they go. You just see what they can do. You gather up their worksheets like the examples that I've shown. Okay, so over to families then. It's often a really difficult thing. I'm just keeping my eye on the time, but having a basket of stuff ready to go and having the little kit, that, or what you typically might use, you might, if you're like abacuses, you've got calculators, you've got blocks, you've got things that are just ready when the mood strikes. And so you can do the little bit often. And that's the way ads work, advertisements. They don't get you to sit and watch things forever. They just show you little clips like those YouTube ads, just 2 minutes at the beginning, a little bit often, and you'll get the message. So we want to not think, oh gosh, I've got to sit down with my child and work with them for 2 hours or 1 hour or even half an hour. 2 minutes, just there. But you want to be able to do it. You want to be ready. You want to have the gear. So you can see that's the hundreds chart. Things are ready to go. But if it becomes a battle, just retreat. There's no point in fighting. If you're at home and life's frenetic, come back to it though, but come and just let it go for the day. Try something else, do something else, and things will get better as they go along. And so at this point, a bit over, but we've still got about 15 minutes for questions, because I think it's more important to hear what you want to ask about. And I might answer Kara's question first, Monica, because I can see that one there. And she's asked, how do you live with a 17-year-old with dyscalculia, very active and sociable and independent in other areas? And why I loved that question is because, oh my word, that is like my Ruth. My Ruth, oh, she's so fun. I mean, even though she got her year 12 maths, she passed the, with adjustment, she passed the general maths in year 12 at a mainstream school. With the help of a calculator, she could do quite a lot of quite sophisticated mathematics. But the other day, she was wanting to buy her 4 cousins an Easter egg. They were $7 each. And I said, so what would you do on your calculator? And she said, I'd go 7 plus 7 plus 7 plus 7. And then she goes, it's $4. And I thought, oh gosh, but the thing is that it is a challenge. We're living with that. I'm living with that. But what we've set up is workarounds. So she manages her bank account, stresses that she won't have enough money, but she does. And so the relative quantities is a significant issue for her. But what she can do is use things like we've got a savings account and we talk about your money as a bucket. So your pay goes in and your bills come out, and you've got to make sure you've got enough in your bucket. So it's not actually in the amount, it's a visualization, thinking about that. But we have supports around her for her money. Um, but other things like managing her timesheets at work, she uses the digital readout on her phone to tell the time, and she uses the electronic devices really in a sophisticated way. She doesn't take long to learn those at all. Like, she might be shown once or twice and she's fine, but the actual things like the calculation of how many 7 4s, even though she's done that for years and years and years, it just doesn't click. So maybe I got that. But Monica, can I hand over to you now?
Yes, thank you very much, Rhonda. We have some more questions. You can see them perhaps also. One question, isn't the mix of colors in the blocks difficult to understand for people with Down syndrome? Shouldn't it be better to use the same color?
Look, quite possibly. And I just grabbed them out here for us. And I was actually trying to find ones that would show up against my black jacket for you. But typically, yes. And what I had these colors too, that I was trying to show the pattern building up. So we start with one and then we had the extra one around it. But you're absolutely right. And sometimes it's really surprising. So when we were doing a study, and little teddies are popular in primary classrooms here. So you have little teddies and you do, lots of countings of 3 teddies and 2 teddies, and 3 and 2 teddies go off and they go to a picnic. How many went on the picnic? And so all these stories are really engaging for other kids. But we found our learners with Down syndrome got so absorbed in the picnic, and then they're talking about what sandwiches, and they just completely missed the point. So you're quite right. Yep. You know your student, you know what's going to get in the way. And that's why I do have these plain blocks. You're absolutely right. So thank you. Just to show that I did have them.
Yes, I pass to the next question. You talked about giving a calculator to a child. And the question is, even for a young child, do you recommend a calculator? Is it essential?
Yeah, but not only a calculator. So what we would have on the child's desk, we would have writing paper so they can write down the equation that they're working on. So if they're doing 3 plus 4, they'd write 3 plus 4, and then they might have blocks. They might count on their fingers. They might do many different ways to do the same thing, as well as the calculator. So they see that the calculator is just one way of many ways to get the result. And I should have said also the number line. So showing them on the number line. So when we want to teach kids to use a calculator, we say, think before you calculate. So are you going to do it on your calculator? Are you going to do it some of these other ways? But from an early age, they need to have experience with them and get used to different types of calculators.
Okay. I go to the next. Have you heard of other math systems like Numericon or Yes We Can? Yes, I Can. And what do you think about them?
Yeah, I don't know the second one, but I know Numericon, and Torben is on the webinar here too, and he has a system. These are good. Numericon is used a lot in the United Kingdom in regular classrooms. So it's a type of equipment that they use there. And so some of the researchers were thinking, well, I wonder if this is particularly useful for learners with Down syndrome. So it made sense that kids in the UK use that equipment because it's in their regular classrooms. In Australia, we don't use that equipment. So if our students want to do it, teachers have to do something different. And what I've found is that it separates out our kids because they've got this special way of doing things rather than what are we using in the regular classroom. Let's focus in on how to teach that. So in Australia, we don't build to they work up in pairs, and we work to fives and tens because of the metric system. And so it's just a bit different, and these things all work, but there's no special trick. So there's no one method that is going to solve all the problems. They're just different ways of helping our learners to see number. And it's the visualization, I think, that's really important.
Thank you. Another question, do you have any recommendations on telling the time or learning the time?
Yeah, now look, that can be really quite difficult. It depends whether you're using the analog or whether you're using digital. Digital's easy to read, but it's actually quite hard to work out. So if the time is 2:57, knowing that in just 3 minutes, it's going to click over to 3 o'clock. So that's actually quite sophisticated. Whereas if you've got an analog clock, you can see that the time is moving up. And if you focus on the hour hand first, so ignore the minute hand. And in Australian curricula, we would go to the minute hand first, which is actually really difficult because you've got to do quarters and halves. And so you've got fractions, and then the numbers don't make sense, and it's really difficult. Whereas if you start with the hour hand, you can see it's going to be, if it's dead on the 3, it's exactly 3 o'clock. If it's coming up to the 3, it's nearly 3, or it's past 3. So you can actually do a lot. You can read a lot of the time just on the hour hand. And then once they've got that, you can then move to the minute hand. So it's one of those things. Focus on the analog clock as well as the digital, just reading the numbers. That's helpful, because a lot of adult things like time on the phone and so on is in digital, so you need both. But I would suggest start with the clock face first of all.
Thank you. Another question comes from Tiziana. What about the tables of multiplications? Can these be a good tool?
Yeah, and they're a memory feat. They are absolutely they're not people who have difficulty remembering their tables. It's often because of their memory. And there are reasons why they're very, very difficult to remember, because our brains are designed to connect up. So if I say birthday, you probably in your mind see presents and cake and candles and parties and all these other images come to the fore. Our brains are designed for that. But when we start to do number facts, if we say 3 times 2 is 6, it's starting to bring in a whole lot of other facts around about 3 and 2 and 6. And it can get very confusing in our brain. You know, we can be thinking 32, or we can be thinking 3 plus 2, or we can be thinking 3 times 6. So our brains aren't really designed to remember these number facts. And there's some interesting research that says people who've learnt their number facts in one language as a child and then move to another country and lose that first language, they will still say their tables in that first language, because the argument goes, it's so jolly hard to do it. Your brain's done it once, it's not going to do that again. So we shouldn't be too, we should do all we can to help our learners remember our number facts, because the more we remember, the less we have to think through, but we shouldn't focus in on it to the detriment of other things. It should be something that good if it happens, but it shouldn't be something that we don't let them do other things until they know it.
Okay. There's a question from Cara. Thanks a million, Rhonda. We'll try the bucket technique. Lovely to hear about you. Would you still do work on visuals and number lines, or at 17 years, you would quit and move on to other things?
You know, I think this is one of the things we don't know from research. And I think all I can say is, from my family perspective, life is too busy. I am really not the very best mother at these sorts of things. So I just have to put that disclaimer out there. There might be other parents who will continue to do it, but life's got busy for Ruth. And I think now, even though, like, the reason I asked her, what would you put into your calculator for those eggs? Because I just wanted to keep her thinking in that way. She doesn't live with us now. She lives in her own flat. And so I guess, look, if you can, it's good. But I have to be realistic and say I don't.
Okay, I think there's another question in Turkish. Perhaps our Turkish translators could translate it.
Yep.
Or if not, I continue with the other ones in English. Turkish, please. If not, I continue with another question in English. Regarding the memory, I see that my son remembers.
Yep. I'm just going to show you. There it is.
In 3, okay. You can read it, okay.
Okay, so to count backwards, and this is one of the ways they tell if people have dyscalculia. They say it's a lot like the way I know the alphabet. So if I want to know A, B, C, D, E, and I want to say what's a letter back, I have to go forward to go back. So our people with dyscalculia don't remember numbers in that way that we do. They don't have that. It's really hard. So to teach counting backwards, have the number line there and then count back on the number line. So they're reinforcing this visual image. We're helping them build pathways in their brain. We've got a visual image. We're going to go backwards, 10, 9, 8, or as we can see, yes, I have got it sharing, yes. So we can go back 5, 4, 3, 2, 1.
I think there's one question left for the moment, but it's in Turkish, I think. Okay, it's no longer there, the question. So I think we've gone through. Yes, there's my question above. Okay. Okay, sorry. I've missed one question regarding the memory. I see that my son
We
remembers.
sent the Turkish question in chat, via chat.
Ah, okay. Could you say it's about touch points?
Yeah. Okay. Yes, I know of those touch points, and there was a lot of research done about that. When would that have been? In the 90s, probably the late 90s, maybe early 2000s. They didn't. What was found was it didn't help people to go further with their thinking about number. So the idea was that if you had the number 2, you had 2 touch points. So as you went around the 2, you went 1, 2, and then you went to 3, and you went 1, 2, 3. And so it was a visual. It was trying to be tactile around the numbers, but the research hasn't gone to a point that I think it's really not something that people are working on anymore. And it's really because while it gets you through that calculation bit, it doesn't help you to do anything further. So having a number line, it does help you go further, because you can keep going with the numbers. You can go forwards, you can go backwards. And then with the calculator, once you know, well, that's what addition does, but this is the exact answer. That's the answer that I need. So yeah, touch points is really not something I've heard people do for quite a while now.
Okay. This question from Thais regarding the memory. I see that my son remembers whole songs in 3 languages. Why is it more difficult with math? Would it help to do the math tables through some songs?
Now, there's an interesting thought. So long as the songs are different. So yes, and that's actually what you found is something that my dear friend Andre Zimpel taught me. There's that, and those of you who have a person with Down syndrome close in your life, you will know this too, that their long-term memory is phenomenal. A lot of what we read in the books about their memory is actually about short-term memory, and they say it's weak and their verbal memory is weak. But we know long-term memory is very strong. And Andre, he's done research that demonstrates this to be the case. And what you're picking up there is what is this long-term memory. But the issue, and I think it's yet another example of why we think that there's this part of the brain, this small part that's there just for calculation and quantity, is not working. So yes, songs would help so long as it's a different song for every table. Otherwise, you're going to have that problem of mixing up that happens. And so you can get songs around for the different tables that will work. Yeah.
What about money? Do you work only around more or less?
No, I think we need to work quite hard on what are the important ideas around money. It's things of it's actually, it depends on the age of the child. So if where you are, you're still using coins or you're still using cash notes, children need to know how to do that. In my country, that would be less and less important. We would have very few situations where they will need cash. So they need to know how to use a card, but not just that this is the magic card that I tap it and it gives me whatever I want. We have to teach students that this contains money. So that's where we need to then start thinking about alternative models. And that's why I use this idea of a bucket. But that's quite a long, that I think that'd be a very long answer to explain what I think we should do with money. There's a lot of work we haven't yet got in research, and I'm exploring these things with my daughter, with other young people that I work with, but I haven't yet got research evidence, and I can't find it. I've been looking for it around. So I think we got a long way to go to know how to do this. But I think it's going to be parents together working out what works, but also we need to think about how we make sure we support our young people to use their money. Maybe a card, one of the things that we've done, and a lot of families I know do, just keep a small amount of money. So maybe a couple of $100 or 100 euros or whatever it is, so that it's not if they've got enough to use, but if they use it all in one go, it's not a disaster, it's a learning experience. And so that idea that they have the experience and then they work alongside somebody to keep track of it. Online banking, just having the images that banks will provide, seeing where the money is and that sort of thing, getting lots of exposure to it is actually really important. We can't just say, oh, it's too hard, we'll manage their money. We've actually got to give them the opportunity, but then we've got to have these safeguards in place. We've got to have people keeping their eye on their accounts and knowing what's going on. And I think we all get help with our money. We need to have people we trust, but it's quite a different, quite a different. I think there's a long answer, and I've already. I'll stop now, Monica.
Thank you. I think there are no more questions, or if anyone, for the interpreters, could you please translate the question for me? Sind Mengenvergleiche sinnvoll?
And I see Suzanne's raised her hand.
Are quantity comparisons useful?
So say that again.
Are quantity comparisons useful?
Yeah, look,
More, less, equal?
And they're really hard. They're really hard. And so if we think about an alphabet, and if I think about the letter G and the letter M, and I think, is it more or less? It's the same sort of difficulty. And it seems really easy for us, but it is really hard for somebody with dyscalculia. Now, that's still a hypothesis, but it just seems like we're onto something with that. I think it doesn't hurt ever to do lots of practice in ideas of more and less. Who's got more? Who's got less? And you can see it. So you can see this person's got a great big piece of cake and this person's got a little piece of cake. They're really good words to learn. It's really good to keep doing it. But I think what we want to do is just recognize this is actually really hard for somebody. And so if it's becoming a block or they're getting upset, we move on.
There comes a question from Jacqueline. Could you tell us more about the brain areas, IPS, involved in math?
Yes, Jacqueline, I'm not an expert. I'm not a neuroscientist, but the book that has been particularly influential for me is called Number Sense: How the Brain Makes Mathematics, and it's by Stanislaw Dehaene. But there are other people writing in this area, but the neuroscientists are still working on this. It's a new field even for people without Down syndrome. So they're working on it for where they first twigged to it was people who'd had strokes. So their brains were doing calculation and understood number perfectly fine. They had a stroke, so they damaged part of their brain and they lost the ability to understand quantity. So that's how doctors first twigged that there might well be a part of the brain that does this. But the neuroscientists haven't yet agreed on the mechanism. So some think that there is a module in the brain that does calculation and quantity, and others say no. Those who say it is in the brain, they will say it's the interparietal sulcus, which is part of the brain, and apparently it's part of quite an older part of the brain that's not where the language centers are. But that's about as far as I am. But my email address is on the screen. So if you email me, I can forward you some articles by some of these neuroscientists. But when I was reading about what they were thinking about and the sorts of issues that were coming up for people who had these problems, it just sounded to me so much like all of the hundreds and hundreds of people with Down syndrome that I've come across that have this problem. And it's the beauty of growing up alongside with my daughter. You know, you just live with these challenges and you think, yeah, there's something going on here that's a lot deeper than just we need to find a clever way to teach this. There's something else going on. So if you want to email me, and if anybody wants to email me with other questions or points, you know, I'd love to be in the conversation. Sadly, I only speak English. I'm really, really sorry about that. But yeah, maybe other people could, if you want to email me, you could email me through perhaps people who do speak your language and English as well. But I'd be very happy to forward on any articles to Jacqueline.
Well, I think there are no more questions. I can't see anymore. So I would like to pass to Dinka again. Thank you very much, Rhonda. And Dinka, please, could you continue?
Yes, yes, thanks a lot, Rhonda, and also thanks to all participants on this webinar today. Maths is love not only of Rhonda, but also some of us who are quite a lot of involved in this maths teams. And I could say that ETSA will continue with maths, with the new webinars as well. Rhonda is for introduction, I could say, and a very, very good introduction that we could start from some points of the maths. But there are a lot of things what our children and youngsters could do in the maths. It's showing this webinar, and I just would like to encourage all parents and all experts that there are a lot of things what we could do. And like Rhonda said, in different part of the world, I will say now world, not just Europe, not just Australia, not just it's America. There are a lot of possibilities what we could do with our children, and to make that maths will be a loved subject of our children. Okay, always will be some children that will never love maths, but with some kind of the games and some kind of the good learners from the beginning, maybe some of them will discover, or we will, like parents, discover that our child could do very good in the math something. And that is a good that we always have a possibility and give possibility to the parents and associations that we find the way for, let's say, each child, what is the best way how they could learn. That means we have to have so many possibilities and choose the best one for our children. Okay, if we don't have some more questions and comments, we could close webinar for today, or wait for minute 2 if somebody would like to ask something more. Monica, do we have some more in the meantime?
No, I can't see any more questions.
Okay, in that case, Okay, I would like to say that we will close today's webinar. Thanks a lot first to Rhonda. And really, it was very great to hear you and your experience and all what you did. And thanks I would like to thanks to our team from Turkey, and also thanks to Monica, Cora, and Maida for preparing all of these things about our webinar. And see you soon on new webinars. Thanks a lot for everybody.